In this video, I'm going to introduce you another concept of numerical method, but this numerical method is using for approximate a integral, right? The value of a definite integral. Okay, as you can see that this will be the graph of fx with value from a up to b. The region is bounded with definite integral, means that we integrate a to b. And from here we have integrate from a to b, which is actually the area under the curve here. Alright, area under the curve. Okay, so besides we using techniques of substitution or integration by parts or any techniques, we can getting the actual value, right? But for this we have using numerical method, okay, because some integral function, some integral will be, the function of the integral will be hardly to have any suitable value, suitable techniques. For example, not all the fx will can using integration by parts, can using substitution or any techniques of substitution. All right, so if this type of function, we usually were using numerical method. Alright, one of the numerical method of evaluating integral will be trapezoidal rule. There are several numerical method in evaluating a integral. Okay, but for now, we introduce you about trapezoidal rule. So, this trapezoidal rule is using to approximate the area. It's not the actual area, it's just using for approximate the area here. So what they do is they divide the graph into strip, okay, number of strip. Okay, we don't know how many strips, so they are going to divide them to a number of strips. So with all equally spaced, sama jarak, equally spaced here. So it means that if I want to get a length for each interval, we have to find the value of the length, right? The length here. So we divide them. So how to do that? So we have to depend on how many interval we need. So h is we're taking the b and the a. Why we taking b minus a? Because b minus a is the length, right? Then we divide by number of interval here. Depend on how many interval we have here. So if let's say a to b have 6 interval, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're going to divide by 6, right? Divide by 6. So for now, we're not sure how many interval we use. So we just want to generate a formula for this. So as we approximate, we are actually using trapezoidal, means we're using trapezium. So we are actually sketching a trapezium along the curve here. Alright, drawing the trapezium. Okay, this trapezium may have some empty space here, which is not occupied. Alright, so why? Because this is just an estimation. Alright, so it's just an estimation. So I just drawing. So means the accuracy of using this trapezoidal rule is still need to be discussed. Right, we have to improve. Okay, for now you just need to understand how to generate the formula. So for here, let's say I'm going to rewrite the a and b as the value, alright, I just write here as x1, okay, and this one to be xn, means there are many strips here. Okay, for here I'm drawing 6 strips, but no, it can be many strips. Okay, so x1, and this can be your x2, x3, x4, so on and so far, xn up to xn minus 1, xn, right? There are many strips. So okay, for example, this one, the coordinates here will be x1, y1, right? Because during x1, you substitute x1, you get different value of y, right? The height here will be different. The height here is y1, okay, y1, and the length of this will be y2, right? You will have x2, y2, x3, y3, so on and so far until the last one, which is xn, yn, right? This is your yn, means the length here will be yn, and the length before this is yn minus 1, right? yn minus 1, and this will be your y1, the height from here to here is the value of y here, right? The height here. So it's y1, this is y2, y3, y4, dot, until yn minus 1. So, so now we have divided them into A1, A2, A3, have how many trapezium? Up to, okay, 1, 2, 3, 4, 5, up to an minus 1. Alright, so we have, let's say if you have six ordinates, this is called 1, 2, 3, 4, 5, 5, okay, 1, 2, 3, 4, n strip, n ordinates, okay, ordinates. So you will have n minus 1 strip. For example, if you have 1, 2, 3, 4, 4 ordinates, 1, 2, 3, 4, 4 ordinates, then you will have 1 trapezium, 2 trapezium, 3 trapezium. If you have 4 ordinates, 1, if you have x1, x2, x3, x4, 4 ordinates, we divided this one to be 4 ordinates. Then we have 3 trapezium. It will be less 1 trapezium. If you have 6 ordinate, 1, 2, 3, 4, 5, 6, then you will have 1, 2, 3, 4, 5. 5 strip or 5 interval or 5 trapezium can be drawn. If you have 6, you have 5 trapezium. So for example, you have n ordinates from 1 up to n here. You have n minus 1 trapezium that you can draw. So now, how to find A1? As you know that the area under the graph from A up to B can be approximated by adding up all the area here. The area for trapezium A1, trapezium A2, A3, A4 until the an minus 1. Total up the area of the trapezium. It will be almost the same, nearly the same as the actual area of the graph. Okay, why we say approximate? Because can you see there is an empty hole here, right? Empty space here, which is not occupied, which means that it's just an approximate. Okay, just an approximate. So how to generate the formula? Okay, let's see. All right. Okay, let's start by adding the first trapezium, the second trapezium, the third trapezium, up to the n minus 1 trapezium, right? So means that you have n minus 1 trapezium here, right? You adding up the area is actually, we can say that is approximate to the area under the curve, which is integrate from a to b fx dx. Can you see? It's just an approximate. So how for A1 will be the formula for trapezium. Okay, what is the formula of trapezium? Okay, the trapezium will be looking like this way. So we try to add up. So trapezium, let's say this is your A and B and this is your H, right? H. That's why I represent all this with H. H is B minus A over N, right? Depend of how many interval here. So the length of H is always the same. It's a constant. Alright. So and the value of A and B is changing. It depends on the Y value here. So the area of a trapezium will be half. The formula is A, right? 2 parallel side. We add up the side, the length of the 2 parallel side, which is A plus B, multiply with the height. Right? Multiply with the height. So, okay, for now, I'm going to add up one by one. For A1, you have 1 over 2 H, right? 1 over 2 H. The H is the length here. Alright? Everything here will be H. Okay? Trapezium A1, trapezium A2, A3, A4, up to, they have the same length. Or is H. Okay, the height of the trapezium, H, multiply with A plus B, right? A plus B. A plus B here is, the A here is either this side is parallel, right? These two sides parallel. So I'm getting Y1 plus Y2. Y1 plus with Y2. Alright? Y1 plus with Y2, followed by A2. Which is half H also, right? This will be the same. Half h. A plus b. For A2, it will be y2 plus y3. The trapezium here, can you see the trapezium here? Y2 plus y3. So we have y2 plus with y3. For A3, we have 1 over 2 h y3 plus with y4, right? For A3, y3 plus with y4 is still h, right? Up to the last one will be 1 over 2. This is the area for n minus 1, okay, which will be h yn minus 1 plus with yn, right? Can you see that? yn minus 1, because this is xn minus 1, and for this is a xn minus 2 or yn minus 2, right? Yn minus 2. So if you keep writing, you adding a trapezium means that before this you have 1 over 2 h yn minus 2 plus with yn minus 1. Just like if this is 6, this will be 7, right? 6, this will be 7. 6, 7, 7, 8, right? 7, 8. So means that, okay, now what we're going to do is, I'm going to generate the formula by looking all the constant that I can factor out. Okay, I can factorize actually all this is the same, right? Half h, all are the same. The value are the same because of the length are the same. The difference is the sum of this value here. So I'm taking out all the value. I have 1 over 2h. The remaining will have y1 plus y2. Because I have taken 1 over 2h out, I have y1 plus y2 plus with y2 plus y3 plus with y3 plus y4, y3 plus y4, and if you continue, if you keep continue, you are getting y4 plus y5, right? So if you see, so now plus with yn minus 1, yn minus 2 plus with yn minus 1 plus with, yes, this one already taken out, right? Plus with yn minus 1 plus with the last one is yn. What can you observe, right? What can you observe from this formula? The most important thing you can observe, y1 is single, is alone, right? Is alone. y2 got both. Can you see? There is a y2 here, right? So I can show you that actually y2 is double, right? It's double, and y3 also double. All the middle one all double. y5, okay, y4. So until yn minus 1 and yn minus 2 and the before one, but the value y1 stand alone, the n value y stand alone. So it means that finally we can conclude the formula of the trapezoidal rule, right? Okay, the formula will be integrate from a to b fx dx can be approximate, right, by half h, okay, half h, where the y1 and yn I write in front, right? y1 and yn I write in front. Why? Because y1 and yn is stand alone. They have no other y1, and yn is also, and y2, y2, y3, y3, all the middle value will repeat with twice, right? For yn minus yn. So only the last and the start we're getting alone. So plus with 2 times, 2 times. So y2 plus y3 until yn minus 1. So if we calculate, if we adding up all the area of trapezium, we will approximately same as the area under the graph from A to B. We just use the word approximate. That's why trapezoidal rule is a numerical method to approximate the definite integral here. So I've already generated the formula for you. So as I need to show you how to using this formula, right? So in the next video, I'm going to show you example how to use this formula by using calculator and some table of value, right? So hope you understand why we're getting this trapezoidal rule, the formula of trapezoidal rule. So hope you understand. Okay, see you.